Welcome fellow learners. In this video, we will be exploring how to integrate LangSmith into your LLM based applications. LangSmith is a platform provided by LangChain that supports developers throughout the entire application lifecycle. With LangSmith, you can debug chains, manage datasets, conduct evaluation, conduct testing, and also we can capture production analytics. LangSmith is a kind of platform which can be used with other frameworks beside LangChain also. But in this video, we will be utilizing LangChain to showcase how we can use this LangSmith in our LLM based applications. So let's get started. So before implementing this, you need to first install few things. You need to install this LangSmith library into your Python environment. I have already installed this library. And after installing this, you need to have a LangSmith API key. You can get this LangSmith API key by registering into LangSmith website. So you can go to this LangSmith web page, then click on this sign up page. You will be shown different options through which you can sign up to this LangSmith. You can choose any of these options. Now once you have registered to this LangSmith website, you will be shown this particular page. Here you can see different sections like your projects, your data sets, your annotation queue and others like your prompts and all. The next thing is, to get your API key, you need to click on this setting button, and here you can create your own API key. I have already created one API key over here. You can create your own API key by clicking on this create API key button. Now once you have created your API key for this LangSmith, you can utilize that API key into your code. So you can see I have saved LangSmith API key in my system environment variable. You can save it there, or you can use that directly over here. And you can see another API key that I am using is OpenAI API key. I will be using this OpenAI LLM for the part where I will be implementing a simple LLM application. So let's run this cell, and we will be having this API key, both LangSmith and OpenAI API key, in this particular notebook. Now let's initialize few of the variables over here. So these are the few variables that will be required to utilize this LangSmith API. So like the first one is LangChain tracing v2. This particular variable we need to set as true. By setting this as true, this will save all these logs, whatever we are going to see in our LLM application, into this LangSmith platform. So the next one is this LangChain project. So this one is basically the name of the project that we are going to save as in our LangSmith platform. So this particular project name will be shown in this particular project section of this LangSmith. So like if you go to this project section, currently you can see there are no projects. Once we have completed this application and run one particular invocation, there will be one project name created over here. So this project SQL agent will be created in that particular LangSmith platform. The third one is LangChain endpoint. So this is the LangSmith endpoint, API endpoint that we are going to use. And the fourth and final one is LangSmith API key. So these are the few variables that we need to initialize over here. So let's run this cell. Now to utilize this LangSmith API, we need to create a client instance. So for that part, let's import client from this LangSmith and create a client object. So this will basically fetch all these variables from this environment, and you can see in its doc string. So if you hover over this, you can see different variables that this particular object or instance requires. So like API key, API URL, these endpoints and all. So these all will be fetched directly from this environment, and it will be shared to this client object. So let's run this cell, and this client instance will be created that we can utilize to connect to this LangSmith API. So once we have completed this LangSmith setup, next create a simple LLM application. We are going to create a SQL based LLM application. So we are going to create an SQL agent using this LangChain. So for that part, let's first import an LLM. And we are going to use this GPT 3.5 Turbo 0125 model from this OpenAI. So to do that, let's run this cell, and this LLM will be imported in this particular notebook. Once you have done that, let's create an SQL agent. To create that SQL agent, we are going to use this create SQL agent module from this LangChain community. And you can see in this particular SQL agent, I have passed different parameters over here. So this LLM will be same. The first parameter is this LLM. This will be same, this our chat OpenAI LLM. The second one is database. For the database part, we are going to use this famous Chinook database, and for that part we are going to use this SQL database module from this LangChain community. This database consists of around 11 tables, so we are going to utilize that directly over here. So we will be importing this database in this notebook, and then we will pass that database variable over here. The third parameter is this agent type. We are going to use this zero sort read description. This kind of agent type, first it reason out and then act according to the reason that it has finds. So we will be using this agent type, and the fourth parameter that I have used is verbose equals to true. So this parameter will be used to showcase the intermediate steps that this particular agent has utilized to go into the final output, to provide us the final output. So let's run this cell, and we will be having this agent executor in this notebook. Now let's test this agent executor. So I'm just passing a simple query to it, like how many albums are there. So there is a table in this database also. We can print that table by using this db.table info, and it will showcase all the different tables that this particular database is having. So if we scroll a little, we can find out like this particular database is having this album table also. So I have just asked a simple question like how many albums are there. So let's run this cell. Now you can see what are the different intermediate steps that this particular you can say agent has taken. So like it has first created a query, select count star from albums, but it shown us that it has used this particular action SQLDB query checker, because there is no albums table in this particular database. The table name is album. That's why after this you can see it has find out all the tables available in the database, and according to that it has modified or corrected this particular query. Like you can see it has used then corrected query select count star from album, and it has provided us the final result like 347 total albums are there. Now you can see seeing this kind of intermediate steps and then debugging and logging will be difficult. So for that part we can utilize LangSmith, and as we have already seen, we have created a client which will be basically saving all those logs in that LangSmith platform. So if you go to that LangSmith, earlier we have seen that there were no projects over here. Now after running that particular agent executor, it has created this particular SQL agent project over this LangSmith platform. So now you can see what are the different output that it is providing to us. Like you can see it is showing like there were total 2521 total tokens were utilized, the total cost that it has used, latency that it was having. So these are all the output that it is giving. And to deep dive into it, we can click on this project, and we can see it is showing all other output over here also. So if you click on this drop down, you can see what are the different intermediate steps that it has used. Like you can see what are the different timings, and as per the timings, this was the first one, then this was the second one, then third one, and so on. And this is the final output. So like the input question was how many total albums are there, and output is there are total of 47 albums are there. So like if you click on that, you can see the output over here, the input over here. So this was the final output. But if you want to see the intermediate step over here, you can click any one of them, and you can see all those input and output over here. One more thing is if you want to see only the LLM calls, you can click on this LLM calls tab, and you can see all the LLM calls that it has made in this particular agent. So like you can click on any one of them, and you can then see what was the input that was passed to this LLM. Like you can see this was the complete input passed to this LLM, the initial prompt, then intermediate actions, and the actions and the tools that it has used, and then final thought process that it has utilized. And then finally you can also see the output from the LLM. And you can also see over here what was the total tokens utilized for this particular LLM call. Like it was 577, and you can see the total cost for this particular LLM call also. So in this way we can basically deep dive into this particular LangSmith and see what are the intermediate steps. We can also debug over here, we can evaluate, and other things we can do by using this particular LangSmith. So you have seen that I have used this OpenAI LLM to showcase this LangSmith. We can also use open source LLMs like Llama 3 and then incorporate this LangSmith to see different logs and different intermediate steps in any agent and other things. So for that part, we just need to change LLM in this particular SQL agent. So for that part, let's first import a Llama 3 LLM by using Ollama. So for that part, let's just do LangChain underscore community. And from here, we can use this LLMs, and then we can import this Ollama. So importing any open source model from Ollama is pretty simple. I have explained how to use this Ollama install in your local PC in another video. I will be sharing that video's link in the description also. Now we have imported this Ollama. So let's import our Llama 3 model using this Ollama. For that part, we just need to pass the model name as Llama 3 over here. So we can just pass model equals to Llama 3, and we will be having this Llama 3 LLM over here. So let's call this Llama 3, and this Llama 3 model will be imported in this particular notebook. Once we have done that, we need to make few changes, like let's also change the project name. So for that part, let's copy this one and change the project name. So let's say SQL agent with Llama 3. We can also do that in the same project, but I think changing the name of the project would make things more clearer, and we can see and debug things in a more clear way. So let's run this cell. And now one more thing we need to do is, like, we need to again instantiate a client such that it can reflect the changes in the name of the project. So for that part, just copy this one and paste it over here, and it will create a new client by using this changed project name. Once you have done that, let's just pass this Llama 3 LLM to this SQL agent. So just copy this cell, this line of code, write down over here, and instead of passing this LLM over here, you need to pass this Llama 3 and just paste it over here and then run this cell. Now we will be having this SQL agent by using this Llama 3 model. So we will be running this same this particular query using this agent executor that is utilizing this Llama 3. So copy that and let's run that particular query. So as we are using this Llama 3 in this local PC, it might take a few minutes. So wait for a while. So now you can see it has completed this execution. We can see what are the different intermediate steps that it has took. So like it first saw what are different tables available in this database, then look into the schema of this table album, and then kind of created this query, select count star from album, and then find out this 347 as an total number of albums available. But it kind of stuck with some kind of loop, like it again thought of, like, since we need to count the number of albums, it again gone to like see what are the different kind of tables available in this database, then looked into album schema, and then again created this query, and then finally it found the total number of albums are there, 347. But it's okay, here our objective is not to see how does this Llama 3 perform, but we need to see how we can incorporate this LangSmith with this Llama 3 and OpenAI, any kind of LLM based applications. So as we have changed the client earlier, so now we can go to that LangSmith platform and we can go to this projects page. Let's open it in a different tab, and you will be seeing a new project will be created, that SQL agent with Llama 3. Now you can see it has utilized total number of tokens around 4930, which is kind of double that OpenAI has used. Its latency is also quite high. You can then click on this and go to different sections of this particular agent execution, and then you can see what are different calls it has made. You can see it has also made a lot more calls than the OpenAI LLM that we have used. So which is quite obvious, as like this Llama 3 that I am using, it is a quantized version of only 8 billion parameter, while that OpenAI model is having a lot more billion parameters than this Llama 3. So you can see in this way we can incorporate LangSmith with our LLM based application, and this LangSmith will be helpful in various stages of our application lifecycle, like debugging, like testing it out, like evaluating our model. We can also see different analytics that we are going to use in production environment. Like we can you can click on this monitor tab, and you can see different analytics over here, like what are the total volume, latency, tokens over the number of days, like 7 days, 30 days, 3 days. So this was just the beginning of our this series of this LangSmith, understanding this LangSmith. So we have just got started with LangSmith. We have seen how to install and implement this LangSmith in our local environment. So in the next set of videos, we'll be seeing how we can utilize this LangSmith in our LLM based applications to debug our applications better, to evaluate it better, and monitor it better. So great. Thanks for making till the end of this video. Goodbye until the next time.